before going into our lab session, let us go with 4 questions alone. I will need only one word answer as we usually do, right? If I say k nearest neighbors and ask you whether it is a classification algorithm or regression algorithm, what you'll be saying?
Both,
We can
Both.
use it for
Very
both,
good.
classification
sir.
regression.
Great, great. It is going to be used both for classification as well as regression. Another question comes, somebody has come and ask you, shall I use categorical data, that is fully string data for k nearest neighbors? You will say yes, k nearest neighbors are going to support or not support.
Yes, sir. We can use
Yes,
categorical data also by using one-hot encoding. We are converting that
great,
category variables into numerical variables.
very good. We are going to use dummies, right? So let me
Yes.
elaborate one more time. So this k nearest neighbor algorithm is going to be used both for classification purpose as well as regression purpose. When it is going to be classification, my output will be discrete. My output need to be discrete, and I can have more than one class, right? That is actually the case. When it is going to be in regression, my thing is I should have only one class, and the output need not be a discrete. It need to be a continuous term. And as Yugi said, we can actually convert those terms in those categorical terms into numbers by using something called as dummies. I just type here dummies. Here something called as dummies in Python, which will convert the strings into corresponding numerical terms. We'll do that if needed. Whenever we needed, we do that. This is the base, right? Third question: if I was going to use k nearest neighbor, right? Well, what criterion I'm going to use to say he is a nearest neighbor or he is not my nearest neighbor? What I'm going to use?
By using Euclidean distance or Manhattan distance, sir.
Yes, by using any distance measures, I can do those kind of stuffs. I want everyone to say, not only Yugender, I want everyone to say, please be unmuted, right? So I can use any distance measure to say whether this particular point is nearer to another point or not. Final question. If I say k equals 1, if I say k equals 1, it means what? In k nearest neighbor, if I say k equal 1, what it does mean?
Sir, it will k is equal to 1 means it will take the nearer distance for only 1 point, sir.
Yes. Some sites, as I said yesterday, some site will say that if k equal to 1, the point by itself is nearer to it. It is not the case. As per Andrew NG definition, it is if k equals 1, it means that a point nearer to it, another point which is nearer to it in the first closest distance. So these things is enough. These 4 questions, we are able to answer, we can easily crack k nearest neighbors, right? We'll go into the algorithms. I request everyone to have your collab screen on and let us go into it. Before directly going into our laboratory exercise, first we are going to share a normal exercise in k nearest neighbor and apply the same in our own laboratory exercise, right? Let us see our own exercise component that we go along with theory. Let me discuss with you what are the packages actually required, right? So if I want to take a file from a particular place, then that is in a particular file location, what package I'll use? What is the package that is going to be used?
For dataset we use pandas, sir.
Yes, a data sheet. I want to plot
Matplotlib, Seaborn.
Matplotlib or C.
matplotlib.pyplot. Yes, matplotlib.pyplot. Matplotlib.pyplot as XAPLT
ELT.
and cborn also I'll use. Import cborn,
SNS.
cborn as SNS, right? Yes, great. Now we have something called as sklearn. From the sklearn, I have to take k nearest neighbor. But before going directly into the k nearest neighbor, first we already know that rather than k nearest neighbor classifier, there are some other classifying algorithms also available. Like we have a decision tree classifier, we have
Logistic
logistic.
regressions.
Yes, yes. Logistic classifier is there. We have SVM. We have many things available, right? The thing is, why k nearest neighbors? If these things are already available, why k nearest neighbor? To say that yes, k nearest neighbor is suitable for this, there is something to understand. What is that? Is say for example, if I have a whole set of points, and if the
Overlapping.
points are highly overlapping, then I can say that k nearest neighbor is suitable. We have already seen it, so that is not required one more time. So let us go into it. I need some NumPy packages to perform some numerical operations. If not needed, I'll erase it at the last. So these things I'll use, and I'll use inline function also for matplotlib for faster executions. Matplotlib inline. Yes. So these are the packages. Let me see whether the packages are running successfully. Is bear with my net. Okay, this will have it. Yes, it is running. Now I need some data set to operate on. I'll take a data set from Kaggle. I have already downloaded it and kept. I'll take the data set and I'll upload over here. Yes. Let me please wait. I'll open the data set and I'll upload here. It's taken from Kaggle from a GitHub source only, not my own data. Yes, I got the data. I'm just opening. It is loading here the classified data. This what is the thing over this data is this data is actually used only for nearest neighbor criterion in a particular GitHub source, right? That's where I actually taken this already available. What I'll do is I'll open the WhatsApp and I'll put the same data to the WhatsApp also, so you can also use the same data set, right? I hope I'll send to ma'am also, so they can also use it. Let it load. First, let us finish the exercise. Once we find all the exercises very easy, then we can move on to your practical, right? So let us go on. First, I need to read the data set. Very simple. What I will do here for reading the data set,
pd.read csv.
okay. One, we do not need the full syntax. Read the CSV file, just read it. Read dot CSV. But the thing to do here is, if I say read dot CSV alone, it is not. It need to be a CSV file. But let us see here what type of file is actually being given to us. It is not a CSV file. It is a normal text file, right? Normal text file is given, so we can directly read it without any extensions, right? Is equal to pd dot read underscore CSV. Now I'll get it as a CSV file and I'll take the path. What is the path of this? I'll take the path and I'll put here. So this is actually the classified data. If needed, I can directly put also because my program is also in content. Yes, classified data I'll put. Index call is equal to 0. Why? Because I don't need an index. Otherwise, what will happen? For every row, I'll be creating an index like 0, 1, 2, like that. So if it now what happens is my data set will be there. If you see this classified data over here, the data will be present. See 0, 1, 2, like that it is really there. Here we have something like 1, 2, 3, 4, 5, 6, right? This is actually called as index. For every row, I'll be getting an index. So if I say index call is equal to 0, it means that the index call will not be formed, right? I'm saying false, right? Already why? Because I'm having 0, 1, 2, 3 and index present in the data set. So that's it. I read it. So let us have an head over it. Df dot head of this. So this is the data what we obtained, right? So now what you have to do is any other data set. You take any other data set. Number one, you have to check is your target class. Whether this is discrete or continuous, this 1, 0, 0, 1, 1 and all.
Discrete.
Yes, great. It is discrete. Why? Because it is either 1 or 0, true or false, and a proper number. I don't say that 1.6 like that. I don't say a continuous value. So it is discrete. So once discrete output values are there, surely I can use it for classification purpose. Am I right or wrong? Yes, I need chorus answers always. So far, so good?
Yes, sir.
Yes.
Yes, sir.
Yes. So now I have these many features. See, I don't mean what is the features. I have WTT, I have PTI, I have EQW, many things I have, and I have some target values, right? So these things are ready for me, and my data set is ready. A classification item can be done here. I open a new cell. Now what I will do is I'll check the
Scaling.
variables. Great. I need to scale, but sometimes I do scaling and sometimes I do not, right? First, why I do scaling is here I have everything like 0.9, 0.8, 0.6, something going to 1.23, something. A very large thing. If you go as deep as possible inside the data set, it will have something like 0.00002. A very small value will be there. And when comparing to 0.0002, this 1.23 is a very big number. So I need not want to have such huge difference between the data set, which will bias those rows. So what I will actually do is I'll put a small standardization That is, I'll put a scalar over here, right? We already used a scalar in our linear regression also. Same scalar, same code I'm going to use from sklearn dot preprocessing. I say it preprocessing package because I'm going to do these processes, that is either missing values detection, or whether I'm going to do an outlier detection, or whether I'm going to change the type, or whether I'm going to remove the NAs, or whether I'm going to standardize. Everything will come under a package called as sklearn.preprocessing. I import standard scalar. I think it will come directly. Yes, standard scalar. So from standard scalar, I'm going to call, let me create an object for that. So scalar is equal to standard scalar. I got this. Next, what I'll do, I'll fit. So every time we get a object, immediately what we will do, we will fit the data set with input X and output Y to that particular object. Here scalar is going to be my object, and this is actually a standard scalar object. So what I'm going to put, I'm just
Scalar
going to
dot
fit.
fit to target
Right.
class.
Right. Scalar dot fit. I say target class why, because I don't name it as y. I just have it as target class. But the thing is, this target class I don't have any rights to touch. Why? Because it is a discrete item. If I change this discrete item, there is a high possibility for this to change into continuous. I'll say how it will actually change. If I say log 1 or log 0 or something, what will happen? It will actually change it to some log 1 will become 0, log 0 will go to some other values. So what will happen? The values will change. What I have the right to change is only the inputs. Only the inputs I can change. Output I don't have any right to change. Why? Because they are unknowns. Actually, output variable in any algorithm is unknown. I don't have any right to change the output. So what I will actually do is, I'll take the data set. It is present in DF. So in DF, I'm going to drop, as Yugandhar says, I'm going to drop the target class alone. So I'm going to drop target. I just copy this particular sentence and then I paste it. Target class. Yes. So I'm going to drop the target class alone and axis. So it is going to be a multi-dimensional axis. So only one axis is going to be reduced. So I say axis is equal to 1.
One.
Now we fit it. Yes. Now we got the scalar ready. Now we can go and visualize how the data are actually being changed. Right. Now this scalar is ready. It understood how the items are being scaled in different ways. Now what I can do, I can do a transformation. So scalar transformation will happen dynamically based on the largest number in the data set and the smallest number in the data set. So like that it will do a change. So I'll have scaled features will be equal to scalar dot transform of. I'm going to transform. So what I have to transform, I can just take it to a variable like d is equal to, or directly I can take this df dot drop. I can directly take this, take the entire df except the target class and put it into the scalar transform, right? So that I'll put here. Yes, I think this is not copied. Yes, I do it here, right? So this is actually the transformation what I actually require. So I do this transformation and then I execute the particular values, right? I transform it. Yes, no error so far. So now I access small break here. So far, so good, or any discrepancies found? I'm asking a chorus answer from everyone. I'm asking. What I have done is just imported the packages. I just opened the pandas for. I need everyone to be unmuted. What is the use of pandas here?
For importing file.
Great, for importing the files. Matplotlib or pyplot.
To plot the points.
Great, visualization. Cbon, same, visualization. NumPy, we didn't use it so far, just a
Mathematical
numerical operation.
calculations.
Right, great. Now what I have done over here,
We are reading the data sets
great,
and
great,
printing the
lovely.
first 5 columns
Yes,
using
I have,
sheet.
yes. If I didn't put index call, another column will be formed and it will be saving 0, 1, 2 like that. An index will be great. I don't want that because I already have that. So this is the case. Now I come down. Here I found that the data are actually highly deviated. Some is having value 0.9, and some will have a value like 0.000 something. So I need to form a standardization over it, an optional step based on the developer. The model developer can do that. So I take the scalar from the pre-processing package of sklearn and I apply the scalar object. I drop the target class. Can anyone clearly say why I'm dropping the target class? Yes, if not, if within 5 seconds I didn't get any reply, I'll say the answer.
It will make continuous, sir.
Yes,
Continuous data.
if I act to do pre-processing over it, surely the transformation will make it to continuous because I don't know what happened to that. So I don't have any right on the unknown variable. Actually, this is an unknown for me. If I don't know out of this which is going to be test and which is going to be train. If one is going to be test and I'm acting on the variable one, then I don't have any right to touch this 0. So I don't touch the target value for any pre-processing activities. You have the control over these x values. Don't touch the y value, right? So I have this ready. Next, what I do the scalar transformation, right? I do this. Now, what I will do is let me go and check how my data set is actually formed. And I want to convert the entire data set into a data frame. Why? Because my algorithms, my sklearn will accept data frame only. So I'll convert everything into a data frame. Again, df is equal to td dot data frame of I am going to take what are the features. These are the scaled features. So I don't take these scaled features over here. So that is what going to be present here. Scaled features. And how I'm going to change is what are the columns you actually need. So what are the columns I'm going to take is columns is equal to df dot col. It is not giving me the spelling. Yes. So df dot columns. And what are the columns you need? You can specify in the slicing operator. So if I'll say something new here. Here, this will be what is the index of this particular column. Can I call it 0? 0th column? Yes or no? Yes, can I call it 0th column?
Yes, sir.
This
Yes,
is,
sir.
what is this?
First one.
2, 3, and 4. Come in reverse. Come in reverse.
-1,
One.
-2.
Which is -1 here?
First column, sir. Target.
Target class is going to be -1. This is
-1.
-2, -3, and so on. Right?
Yes.
Now I just put some slicing over here. If I put 0:4, what are the things going to come? 0th column, first column,
First,
second
second,
column,
third
third,
Third.
fourth
column.
will come or not? Fourth will
No,
not
sir.
come.
No, sir.
4 minus 1. I say 9. Up to what it will come?
Up to 8,
Up to
sir.
8.
Up to 8. What will come now?
Only
Eighth column
Only
only, sir.
8 colon 9. Now I just delete this. Now what will come?
0
Up to
to
8th column, sir.
0 to
Up
9.
to
If
8.
nothing is given, it will take everything. Now total rows and total everything will come. Now a small change here. You can say what will come, what will not come.
From reverse.
See, if nothing is there here, what will be substituted here? From the starting. From the starting, I'll take everything.
Starting
But
to -1.
the
Except
-1
target
will
class
not
will
be
come.
considered. Yes, except target class because target class is -1. So except the target class, I'll be getting everything, right? So because I don't pre-process the target class. Am I right or wrong?
Yes, sir.
Yes. Both the D section and E section I'm asking. I want a chorus answer from everyone. Otherwise, a small thing will happen. They'll be saying something like attendance. Now that alone will not be there for one period alone, right? Not more than that. Okay. Yes. So this will be the case. Now I do this and I put a head also. So let us see how the data frame has changed. See, there is a change here. 0.9139 have become -0.12. There is a change over based on the median values, based on the max values and first values. There is a change happened here, and this change I can call it as a scaled value or a normalized value. So usually, if a scaled operation is done, then it means that bias is actually removed. Bias is actually removed in the data set. Otherwise, the rows having larger values will dominate the smaller values. Okay, so those things will actually happen. Right now, I go to the now it's all the scaling operations are completed. Now, what we have to do is now we can have to go and see why k nearest neighbors need to be applied over here. Why k nearest neighbors? So, if I want to apply k nearest neighbor, I need to prove one thing. As in during the start itself, Yugender and Pujita, I think so, said that only when the data points are overlapping, I can use nearest neighbors. If they are not overlapping,
Sir,
I can put a straight line. Yes, somebody called me.
you can message in chat box, in group, sir.
Yes, 1 minute. Actually, my WhatsApp is not working. Sir, we reached. We are unable to reach max limit reached. It reached max limits. Oh, that is a problem. Oh, what I can do for that? I don't know.
Create
For max
another
limit,
Google Meet link.
create another Google Meet link so I can speak directly over there. Huh?
Yes,
Okay, I
sir.
think, ma'am. I think.
Share that screen also,
Okay.
sir.
Can you share the D section link also here? E section link also here in our WhatsApp group. One minute. E section link. Deepak, can you share the E section link to Yugender and his classmates? Deepak,
Okay, sir. Okay, sir.
yes, please share it soon. So I also share it to me also. I'll also join there.
Raja, many students are not able to join it.
Yes, sir.
I'm getting calls
Yes,
from
sir.
them.
Yes, yes, ma'am.
So we can do something for that, then we will.
Yes, ma'am. I'm getting E section link and I'm joining in there also.
Okay.
Deepak, please put it in the chat box.
Sir. Okay.
Now,
Yes,
what I
sir.
have to do, I should
sent,
join
sir.
there also. Huh?
Yes, sir.
Yes, sir. You should join and share the screen, sir.
There also I can share parallelly. Na?
Yes, sir.
Yes, sir.
Okay.
I think it's not working, sir.
Let me do whether it is working or not. You have to say. Is it working here? I should on this mic also. Huh?
Yes, sir.
Okay. Friends, are you able to hear me in this new link? Yes, thank you. And the screen is also visible, right?
The planet.
That's great. Yes. This is called parallelization, virtualization, parallelization, whatever you call it.
Yes, sir. Yes, sir.
This is also one mode of learning.
Sir, but they can't hear this voice, our voice, sir.
No, your voice no need to hear at all.
No need.
Okay, so, okay. Yes. Okay, Yugender, everything fine here, right? Please, Yugender, I want you to take care of this particular link. I'll be going there. And if any doubt is there also, I can hear, but what I'm speaking, what their link people are speaking, you cannot hear. So that is a problem. I want Praneeth, Yugender, Jayant, Andal should to take care of this link. Achyut, you also is there. Achyut, shall I start, Yugender? Yes. Yugender? Yes. Shall I start, Yugender? Yes. So we are in the scaled features. So what we have done so far is we have the set of inputs and we have scaled it. Only the thing is we have removed the bias in the particular data set. Now what we have to do is we need to say, yes, this particular data set requires nearest neighbor. They cannot be used with either decision trees or logistic regression or SVM or kind of classifiers. So what I do is I already have the Seaborn available. I put a pair plot. So what is pair plot is, pair plot actually takes a two-dimensional view with respect to a third variable. That third variable will define the variation between the x and y, what you give. For example, I give df. In df, what are the things are available? WTT is available, PTI is available, EQW, SDI, everything is available. So everything I'll be putting a pair. What is the relationship between WTT and PTI? What is the relationship between PTI and EQW? What is the relationship between WTT and SBI? Everything I need to understand. Why? Because If a new point is going to come with new WTT values, I need to identify in which pair it is going to fit. Right? I'll put a pair plot and I'll say a hue value. What is hue is, hue says in which way factor I need to variate and show the point. If I show you, I will be able to understand that. I use target class for that. Target class, everything is in caps. Target class. Yes, this will run for a while. It will take time. Okay, some error is coming. Let me check. Target class spelling is wrong. Okay, what is the correct spelling of target class? I'll copy here better. Target class. Let me check again. 1 minute. We get a target class. There is an exception in target class.
DF target class we have removed now, sir.
We have removed target class. Oh, okay. So I substituted in DF itself. Sorry. Okay, that is actually. Thanks, actually. Then I'll run this one more time. DF. I'll save it in a separate name.
Or copy that, sir.
No, don't need. I no need. I'll change this to DFS. Okay, I'll change it to DFS. I come to here. Now this DF will have target class. Now let us see how the C-bond pair plot is going to appear. It will take time because we have so many variables present. And what will actually come is how the pairs are going to behave with respect to each other. Whether their points are more clubbed together or they are less clubbed together, whether there is any overlapping or not. How the standard normal plot is looking for those pairs, everything will be seeing here, right? Let us wait for that to execute. It will take maximum 1 minute. Yes, it came. That is also one of the reason for this slow execution. It's finally it came. Let us individually see how the plots are actually behaving. Right? Let me zoom the screen somewhat. Right? Can you see WTT here? Yes, can you see WTT here? Yes. So these are actually the WTT values with respect to its other values. If you see here in the data item, only the numerical values alone will come in the pair plot, because we know that nearest neighbor criterion will use only numerical values. So we took only the numerical values. Now, if you see here in the bottom, they'll have WTT, PTI, EQW, everything. How WTT is actually distributed with respect to other values. That is actually the case here. That is, this is WTT versus WTT. So we know this. See this particular point alone. We have on top, we have some orange points, and on bottom, we have some blue points. Now, the question to you is, you don't think of any machine learning. I'm just asking whether the blue points are in between the orange points, or orange points are somewhat between blue points or not.
Yes, sir. Blue
Yes,
was
it is there.
between orange.
Yes, sir.
Great, correct answer. Right? Can I put a straight line in logistic regression? I can have some straight line or a sinusoidal wave, or in SVM I can have a hyperplane. Can I put an hyperplane and separate orange and blue separately or not?
Sir, we can. It's
If
overfitting maker, sir.
Yes, exactly. So if you speak more technically, as he said, overfitting is required, but I cannot go always to overfitting. So I cannot put a straight line and separate orange and blue. Similarly, case see these are all most worst. See, more orange are between this blue and more blue are within this orange. You see many points, there is a huge overlapping. See, some points like this and all, if you see how much overlapping is there, this and all completely overlapped. See, the normal distribution says that the other variable is actually within the another normal variable, right? So more overlapping is actually present. So I cannot directly use any logistic regression or SPM. So in this case, I eliminate logistic regression cannot be used for this classification data set. SVM also cannot be used because I cannot put a hyperplane and separate. Now somebody come and ask, so okay, logistic regression don't want, SVM don't want. What about decision trees? Even if it is decision trees, what decision trees says, if there is some overlapping, okay, I can use decision trees. If you see these thing and all, everything completely overlapping is there. And if you take these points, many blue points inside the orange curve will be considered as fully what it is actually fully is going to be outliers. And orange within the blue will be fully considered as outliers. If you say like that, so all the outliers, if I remove or take any action, the data set will fully be vanished. So I cannot go for those outlier exclusion also. So the only chance what I have so far learned algorithms is I can go for the nearest neighbor criteria. So the thing to understand here is if there is more overlapping between the data points, the only thing what I can go and do is the nearest neighbor criteria, right? I am making the point clear on why we are going for nearest neighbors.
Yes, sir.
Yes, if I say like in a question, if I ask you or if I give some choices and ask which particular data set is suitable for outliers, what you will say? What you will say for outliers if the data set is more noise?
Decision trees.
Great, very good. Decision trees.
Decision trees.
Yes, in one link and both, I think both links I got to answer. Decision trees. If the data set is having points that are somewhat mutually separable or a linear characteristic is available, then what you can use? Somewhat,
Clustering algorithms.
yes, no, linearly separable clustering, okay. But if I linear, can I use logistic regression also, right, for classification purpose?
Yes, sir.
Yes,
Yes,
so
sir.
I can use a logistic regression as well as I can have an hyperplane SVM also. And if there is more overlapping, close your eyes and say, yes, nearest neighbor is suitable, right? But I say already added, nearest neighbor has one drawback. This is a very basic algorithm. It will not consider any point as an outlier. Even though it is an outlier, it will not consider it as an outlier. It will take that into account. But to get rid of that, what you can actually do is you increase the k value. You increase the k value so that you will get a better result, right? We will see how to find the better k value also, right? So far so good, right? No doubts, right?
Yes, sir.
Yes. Both
Yes,
links?
sir.
Yes, great. Now we are going for, as usual, the train test split, right? So I go for that from sklearn dot linear model. Linear underscore model. Import. I think some choices will come to me. Link
Train test split.
train underscore test underscore split will come, right? NSS.
Yes, sir.
Maybe package is different, sir.
From
Linear
sklearn
model.
dot. Okay, model selection. Sorry,
Model
I mean model
selection, sir.
selection. Model selection.
Selection.
Linear
From
model
sklearn.
selection.
Now I get into the values. I just put X train.
X test, Y train, Y test.
Test Y train. Y test is equal to, I can do either 30-70 or 75-25, anything I can do. So I put train underscore test underscore split off. What I usually have is you go and see df is not my value. I scaled and kept here something. This
Scaled with
particular
features.
dfs, I have something here. That is, I scaled and kept here. That scaled values I can actually use. If you use df directly,
Scaled
then and there is no use of using that directly. I have scaled something. I can use that scaled features. So first, these scaled features first I have to take. Next, I'll apply it to data frames. Okay, I'll come over here. Yes. So I just sc scaled features. Yes, scaled features is coming to me. Scaled features, and what is my output variable? Tf
Target
Target
class.
values.
So what
Target
is the
class.
spelling? Target space class. This is my output variable. So input is ready, output is ready, and what is the test size?
30 or 20 or 25.
20 we should not keep. We can have 25 or 30. I'll keep 30.
30.
30. I'll keep
Easy.
30. Let me run and see. Yes, great. No error. So train, test, and split is ready. Now I just call a KNN and finish it. So let me go into the cell. Final thing. sklearn dot. We have a new package here to learn, that is neighbors package. We have something neighbors, some sklearn dot neighbors. Previous algorithm we use some sklearn dot model selection, or we use linear regression packages. Now we use sklearn dot neighbors. Import. Name is very simple. K neighbors. K neighbors. It came K neighbor classifier. See, if you see here, you got one point. K neighbors classifier also came, regress also came. Have you seen that? Yes, now you can understand. Regression also it can be used, classification also it can be used. But many sites may say it K nearest classifier, right? But it can also be used for regression, right? So that is actually the case. Now I just fit everything. Now let us first decide how many values we can keep for K. What value we can keep for K?
One starting.
Yes, starting we can keep it as 1. So K neighbors classifier of n underscore neighbors equals 1. I keep it as 1. Anyway, this 1 is not going to be my efficient value, I know. But let me start with 1 and afterwards I'll try to change the K value. Next I say knn dot fit of input comma output. So what is my input? My input is X train and my output is Y train. Great. Let us run this. Yes, it is running without any issues. Let me test whether it is predicting correctly or not. So I'll go for prediction. Pred is equal to knn dot predict of. Shall I give both X test and Y test or only X test?
X test, sir. Only X test.
It should say what is Y test. Right. So let us go into it. Yes, it is running. Let me see what is the accuracy level. Why we are doing it as the same. Why? Because the same process will be used. Take any algorithm, create object for it, then fit of X comma Y. Same thing we use for linear regression or polynomial regression or coming into K nearest neighbors. Everything we use the same thing. No much more changes. Right. So we done the prediction task. Now we need to see what is the accuracy. One of the good accuracy seeing view is confusion matrix. That view will be very nice to see what is true positive or true negative, right? And false positive and false negative. So I go for sklearn dot metrics.
Import.
Right, import. I can take confusion matrix as well as classification report. This classification report, comma confusion matrix. Both the things I'm going to take. On this next, I'm going to do some cross validations later. But let us first print and see what is the confusion matrix. Print confusion matrix of what I have to compare. This spread is having the yes, correct. This Y spread is actually my output value generated, and actual Y value is what? This Y test. So this Y test and this spread should be compared, and based on that, what is giving the right answer, I need to check. So I compare both Y test as well as spread. Let us print and see how good our algorithm is. So what is this? I say this is true positive and this is false negative. You add these all together, you'll get accurate. But this should be lower. This diagonal should be lower. I get 15. I get 16 here. Totally how much times it is getting false? Getting wrong answers. 15 plus 16 is 31, right? 31 times. So let for a random sample, what I do is I change this neighbor value to say for example 2. I'm not fixing it. It is a trial and error. Let me check whether it is changing or not changing. Okay, I'll run this cell again. I'll go to the confusion matrix. Great. It is actually changing 22 plus 11, 32 increasing. 33 increasing. Right. So some changes is happening. I don't say that it is increasing. Why? Because we know that if it is increasing and I immediately stop and then it will fix to something like local minimum and I need to use some very good friends like gradient descent and those stuffs. We don't want to go there. And I understood that when the neighboring values are changing, then there is a change. Then I need to study how the values are actually being varied and what is a good value. I need to understand. So what I will do, like in the last class itself, I think Yogendra or actually somebody said, the same procedure you use for clustering will use here and how it is.
Error analysis, sir.
Yes,
We
error
can
analysis.
perform error analysis.
Yes, correct. So before going for error analysis, let us print the classification report also, which will give us precision, recall, F score, and support.
Response score support.
Yes. So classification report I'll take of same thing, same parameters I give, y test as well as spread. This is my classification report. Only 89 percentage it is saying 0 as 0. So this is actually somewhat lower value, right? So I need to have something higher for a data set which is intended for classification purpose alone. So I need these accuracy levels to increase at least somewhere closer to 95. Right? Hope you remember we actually take accuracy uh, greater than 85 for a data set which is having more outliers. I think this data set is actually being normalized and not considered for any outliers. So minimum 95 percentage we will try, right? So I'll go for how to find that k value, right? Very simple, a trial and error method. What will be the total size use check? The total size of the data set is going to be some 400 rows. So what I take is I take 40. So k is equal to 1, k is equal to 2, k is equal to 3, up to k is equal to 40, I will take. So I'll take every
For loop.
things. Yes, I go for a for loop. I'll take every items and I check what is the accuracy value each time. And I check the best k value and then I say this is the best k value and I use it. Right? I'll use that. Let me take the error rate as a list because I need to take a list of all the errors starting from k is equal to 1 to k is equal to 40. For I in range of, like we said, it is going to be for loop 1 comma 40. So 1 to 39 I'm taking, 40 I'm not taking. So 1 to 39 I'm taking everything. So what I'm going to do, I'm just to create a k nearest neighbor object. Knn is equal to k neighbor classifiers of, here this time I don't give n neighbors. Instead of giving n underscore neighbors as 1, what I can give here?
I,
Yes, great.
I.
I can give it as I. Very good, very good. I can give it as I, right? Next, what I'll do for each time, I need to print what is the value. Now
We need to
here,
pick the model.
for this I value, I cannot check what is the training and what is the testing. So we know that cross validation is there, which will do both training and testing automatically for a small set of data. So I'll import the cross validation and apply cross validation over here. So if I apply cross validation, automatically training and testing will be chosen, where training will be by default will be 90 percentage and testing will be for 10 percentage. While doing normal training and testing, we take 70-30. For cross validation, if I take a 10-fold, 9 folds will be for test training and 1 fold will be for testing, and so on. I'll get 10 different models. So I'll do that particular cross validation. I'll do it for all the 40 models, right? So on sklearn dot model selection, import cross validation. Let me check. Cross underscore val underscore score. If I am not wrong, it is correct. Yes, it's correct. So I use a cross validation. So I need not perform the training and testing again. I don't know touch splitting again. So directly I take score is equal to cross underscore val underscore score. And what I'm going to take, I need to use the KNN classifier, KNN. And what is the data set I'm going to use? And the data set I'm going to use is in DFS, that is the scaled data set is available. And what is the target value? This DFS is going to be input. And what is the output?
Target class.
Yes, great. Target class. Right? Now, how many fold of cross validation can we have? I can have 10 fold cross validation. If you want to increase, you can increase. I am keeping 10 fold cross validation. Next, I take error rate. Error rate, this particular list, I'm appending all the error rates into this list. I'm going to plot the list and see how whether the errors are increasing or decreasing. So error rate dot append of the result, the score result I take. This score will actually give the accuracy rate. So can I call the error as 1 minus accuracy?
1 minus accuracy into mean, sir.
So I can take that 1 minus score. I take the mean of that, so 1 minus score dot mean. So for the 10 models that is created for this particular iteration, I take the mean 1 minus score dot mean. I do this particular operation, right? So I just run it to check whether any errors are there. Yes, for I in range, so this brackets for I in range, remembering C, sorry, I in range of 1 comma 4. Yes, it is running. Yes, great. No errors is available. Now let us go and plot and see how this error rate are actually being distributed, whether it is having an increasing trend or a decreasing trend. So what I will do, plot PLT. PLT I already do matplot with the plot is available. PLT dot plot of, I can directly say the ranges, right? Range is going to be from 1 comma 40. That is what is the x-axis. X-axis is going to range from 1 to 40. And what is the value for each of the x boxes? It is going to be the accuracy rate or the error rate. So I am having it like an error rate. It is going to be error underscore rate. So that the list value I am having. So the list value I'll use error rate, and I can say some attributes here like color. What color I need? I'll make it blue. And line style, those things if you want, you can actually add it. Line style, optional parameters. It is not required because only one line is going to come. Dashed line, dash line, and for each time, if a particular value is there, you mark the particular x value. If the intersection is there, how I should mark? I should mark with the circle. So O.
0.
If I give, if sorry, it is not O, it is 0, it is O. If I give x, it will put an x for each of the intersections, right? So for this marker, what is the color? For this marker, I can give marker color as go down. For this marker, I can give the color as marker face color as some red. In the blue, that marker color alone will be in red. And size, what is a marker size? Equals 10. These things I do. And we can also set the figure size because it is going to be a 39 models coming into here. I can set the figure size also. So plot dot figure, and the fixed size is going to be fixed size. I fix is like 40 items are there. I normally set to 10 and 6. Right? So x it will go to 10 and y it goes to 6. 10 cross 6 I am having it. So let us execute this and see how the values are going to be there. PLT dot figure fixed size. Let us see what is the error down. Fixed size is not defined. Let me go up and see. Equal, fixed size equals. Fixed size equal 10. Yes. Now let us go down and see how the errors are being changed. Let me decrease the size. Initially, if you see in the first particular level, it is actually around 0.089 something. Next, it is actually going up and then it is going down. Like that, it is actually being going, right? If you see, what we have to say is the error is steeply decreasing when you go after 2. If you see in 3, it is steeply decreasing. In 4, it is also decreasing. In 5, it is again increasing, and it is decreasing in 7. In 9, it is increasing, and so on. So when it is actually being stable, that we have to see. So it is stable in the sense hereafter error should decrease only and will never increase. That is actually called as stability. After this particular point, error will decrease only and error will not increase. That is actually called as stable. We cannot assure that even a small point will increase. Some small increase can be there, but a steep increase should not be there. So I can consider from this point, if I go down this particular area, after this particular area, if you see, it is actually being somewhat stable. There is some steep decrease only, and there is no that much increase. Only steep decrease is available. So if I see, and here also, after this particular point, 21, 22, 23 maybe, at 23, one increase is there. That is after that increase, it is actually decreasing. This is actually the highest increase point. This is if we set this as an k value. After that, only the error is going to minimize only. It is not going to increase anymore. It is only going to decrease. So this such a k value I have to select. So after a particular point, I should not find any point misleading. It should be like k only, right? So what I will
23
do?
best, sir.
Yes. So
23.
I'll go here and I'll set k value as 23. I go up, and here I'm having that n neighbors. What I can fix here?
23.
23. And before going for 23 values, check here. I'm having 15 here and 16 here in the error columns. And if you go in the precision rate, it is actually 90, right? So go up and we execute this 23 neighbors. Let us see
Sir,
whether
it
it is
changes, sir.
increased.
4 to 13 it came, sir.
Great. Great. Very good. Computer already executed. So I'm getting 9 and 11. I'm getting like that. Right? It is a random, right? 30. So I'm getting 9 here and 11 here. Let us go and see what is actually the thing in the classification report. 93. Yes, typically an above range. Previously we got 90, and I got the accuracy somewhat an increased report, right? So I'll repeat one more time from here. We took an overlapping data set and I confirmed that it is going to be a k nearest classifier. And overcoming here, I just done a train test split and we found a k value, right? Now I'm asking you a question. Just three questions I'm going to ask. Question number one: what is the use of finding this particular parabola?
Sir, we can
Yes.
we can by
understand
using this
which
pattern
type of
మనం
algorithm we need to use.
Very good.
Yes,
We
sir.
can understand which type of algorithm we have to use, right? Yes, I think
And we
another
can
link.
also find the how data is, sir, whether the data has outliers
Yes.
or overlapping.
Yes.
Based upon data, we can choose our algorithm.
Great. We can, based on the data, we can choose our algorithm, right? Now, in this, what you actually see, there is overlapping or no overlapping?
Overlapping undiga?
Yes, it is overlapping. Now we can find something which is not at all overlapping. I think every value is actually overlapping. I can say this
Yes,
is
sir.
slightly overlapped. This is until completely overlapped, right? So that is actually we go for k nearest, right? And why we do a neighboring trial error method? If I increase nearest neighbor, what will actually happen? I can get a better result rather than n neighbors is equal to 1. If I increase the value, I could get some better result. That is actually the thing we actually aim for, right? Yes. So far, so good for everyone.
Yes, sir.
Yes, great.
Yes, sir.
Yes, yes. I think another link also. Yes, everything is going good, right? Yes, great, right? So for E section also, Murali, Deepak, Krishnan sir, everyone, it is fine, right?
Yes, sir.
Yes, great.
Yes, sir.
Yes, sir. Yes, sir.
If any doubts is there over here, please let me know.
Okay, sir.
Yes, great. Now shall we proceed into your own practical? You can start practical. I think some students are very fast. They have done and send me screenshot. That is as usual. I want everyone to try this now, right? Let me have this. With the same thing, I'm not going to change any code here. With the same thing, I'm going to copy something over here and make it our own lab exercises. But some small changes need to be done. Why? Because these features are different and our lab feature is a real-time question. Taking a data from ESPN Crick Info and doing so, right? That is actually different. Now let us first do this, right? Yes. Right? Yes. We can start doing this, and when you want to me to go down, I'll go down. Right. Yes, randomly as usual, I'll be picking someone. If they are not able to show, they'll be given some time, and after the time, if they are not performing, I'll take only one period absent, not both the period. One period alone, I'll put absent. Yes. I'll go to Tara Singh.
Yes, sir.
Yes. Are you doing the program or going to start the program?
I'm doing, sir. But
Okay.
data set is not available, sir.
Oh, sorry, I didn't send the data set. Very
So
sorry, very sorry.
serious.
Very sorry, very sorry, very sorry. That is my problem. I didn't send it. 1 minute. I'll share in the AML stream group. Okay.
Okay, sir.
Centra, send. On the way to Andhra.
In flight, sir.
No, through cycle. That much slow net.
Reach it, sir.
Reached, not here itself. It not went. Saying phone not connected.
Achyut sent, sir. Achyut sent.
Achyut sent. Okay.
I think he's nearer to Kalasalingam.
Isra. I also sent. Achyut front seat. I am berth. I didn't get berth in the front, so I went back. That's it. Yes, proceed with the same. You can take screenshots and you can start. Shall I move down? Shall I? I want everyone to get unmuted. If you want any doubts, you can ask. Right? Just the same nearest neighbor thing. We have seen it on sufficient detail. Not more than that. We have to speak on the classification of classification view of k nearest neighbors. Right? So shall we proceed for checking it? Let it check in E section
Sir,
also.
for me, it's not supporting, sir.
What
See.
not supporting?
CSV, sir.
CSV not supporting. Na say support. It will support.
Okay, sir.
Your laptop only, nada.
Auto.
Your not your laptop, na it will not support. Your laptop, na it will ask your question.
Wait, sir, I will say.
What is the problem? What is the problem?
It will asking the app not installed, sir.
Oh, that extension file is not there. You are doing it in mobile,
No, sir, laptop only.
Laptop only means it will support. Just download it and then if you go here, click this button and then say upload. That's it, right? You don't open it and see. If you want to open it, see, right click and then click notebook. Sorry, notepad. Right click and open it in notepad. Notepad. Don't open directly. Then it will say app not supported. Ma'am, ma'am is.
Yes, Raja, I'm here.
Ma'am, yes, ma'am. Ma'am, you wanted to say, ma'am?
Data.
Ma'am?
What are you asking? I don't get you.
No, ma'am. If you want to add some points, you can add.
No, you carry on, carry on.
Yes, ma'am. Okay.
Let it go in one flow.
Okay. Yeah. Kritik. E section. Kritik. Are you doing? From in which cell are you? Now only started. Very good. Very good. By 12:30, I'll be checking it again, Kritik. Okay, Kedar Ishwari, as usual. Kedar Ishwari completed, huh? Kedar Ishwari. Okay, no issue. Okay, let me go it. Here. Bhanu Prakash. Bhanu Prakash. Yes, doing okay. Anyway, by 12:30 or some time, if I call you to share, at least I need some outputs to be present. Network issues, those things can be there, and the screenshot should come to my mobile also. Thank you. Next, yes, ma'am.
One scroll down, sir.
Yes, scrolling down. Am I in the right cell? Can I move down further?
Yes, sir.
Yes. These are the outputs, and this is the input cell. Shall I move down? You are taking screenshot only, right?
Yes, sir.
Yes. Okay. Shall I move down?
Yes, sir.
This alone is a line. For this line, this much output. I'm printing pair plot for entire inputs with the target class as my blue. I didn't explain one thing that I'll try to explain here. I have target class as hue, right? Why these blue and orange came? Why? Because if you see here clearly, can anyone say why blue and orange came?
Sir, the target variable is in zeros and
1
one,
and
right?
0.
Great, great. Blue color is for 0 and orange is for 1.
One is
So,
to
so that
one.
is actually the purpose of hue. If you give any variable in hue, based on that variable, color will be set. Okay, it's great. Yes, what I'm doing here is here in the score, I'm getting the cross validation score. I'm getting the KNN model, and DFS is actually the scaled value, X values. If you go up and see in the DFS, I get the data frame, entire data frame, the scaled values, everything, except the target class, I'm getting everything in DFS. These input fields. So input I'm giving here, and the output is also ready. So if you do it in output, I take the DF target class as output, and cross validation score, number of cross validation is tenfold, right? So I'm getting the score. So this score I'll get as an accuracy metric. That is, I'll be getting an accuracy for 10 different models. And if I take the mean of those scores, I'll be getting the mean accuracy level. If I take 1 minus accuracy, what will come? Error, right? I append the error for from 1 to 39 different k values. I append all the errors and put it inside a list. So error rate dot append of all the error values, the mean error values. I put it inside there and I plot that error value here. So for 1, what is the error? For k is equal to 2, what is the error? 3, what is the error? That will be there.
Sir, 1 minus 5, sir. 1 minus
Yes.
dot mean.
Score actually gives me accuracy. If I say 1 minus score, it will give me error.
Okay, okay, sir.
Yes.
Understood.
Right, right.
Hello, sir.
Yes, pa.
Sir, for testing, as Yugandhar said, why can't we give like 25, 35?
Yes, if
Like
you
that?
want to give 25, 75, you can give. 20 is not allowed. Don't give 20. Why? Because if you give 20, surely you have to use cross validation here itself. That cross validation I use separately for other k values. So minimum 25 you give. 30 is, means 70% for train. You change it to 25. There is no issue.
And once you scroll down, sir.
Yes.
At last, for in for loop, used from 1 to 40. So the 40 means that range.
Yes. I'm going to take from k is equal to 1 to k is equal to 40 in the sense 40 in the sense up to 39 in the range function. For k is equal to 1 to k is equal to 39, I'm going to take all the k values and then I'm going to find the result. What will be the score? If k
What
is
is
equal to
the
1, what is the accuracy? If k is equal to 2, what is the accuracy, and so on.
from which you taken that 40 length, sir? Like,
Okay, that is a nice question. The whole, if you take the classified data, I'll open the classified data here. Yes, if you open and see here and go till the end, you'll be taking around some 1,000 records are there. So for 1,000 records, as you can either take a root of 1,000 and take that as a maximum value, it will be around 33. So that 33 you can actually use here, or you can also use 10 percentage of the data, 10 percentage of the data over here. We take 40, that is the root of 1,000, maybe around some 33 something. So we use 40 here. you want, you can also increase and see how the k value is being distributed. Even though it is 40, I found a range here in 23 itself that it is actually stable. That is not increasing more than that. That is how I found 40.